Why controlling and how to control loudspeaker directivity? We want to control directivity of loudspeaker in order to achieve a strong direct sound over the audience, in order to have high speech intelligibility. Also, we want to have an even coverage of the audience for good acoustic comfort. There are many ways to control directivity. First of all, the gradient methods. Like for example, a loudspeaker is basically bidirectional. If we place a loudspeaker in a cabinet, then it would tend to be omnidirectional at low frequencies. And if we combine the two, then we obtain a cardioid pattern, which is often used in microphones, but also in subwoofers. Other method, for example, horns. Horns are very widely used, both for controlling directivity and also to increase the efficiency of the loudspeaker. There are ultrasonic methods, more recently, which consist in modulating in the audio band ultrasonic carrier. They can yield very highly directional directivity, but not in the low frequency and only with limited SPL. Geometric arrays consist in aligning a number of loudspeakers along the wavefront corresponding to a desired coverage. And there are many such systems now in venues, concert venues. Other technique is the electronic arrays, in which the wavefront is controlled not with the position of the loudspeakers, but with filtering, DSP filtering most of the time, and essentially with delays and gains and FEAR filters. The advantage is that the array is vertical, so it can be well integrated visually. That's column loudspeakers most of the time. Other advantage is that the directivity can be controlled by software parameters, so very simply, as opposed to the geometric arrays, which needs to be taken down in order to modify the directivity. The disadvantage is that it requires many channels in order to control the directivity, and therefore more cost for processing and amplifiers. Hybrid arrays are a combination of the geometric and electronic arrays. The advantage is that a high number of loudspeakers can be assigned to a limited number of electronic channels. Like for example here, 30 loudspeakers assigned to 6 DSP and amplification channels. This is an example of such a column loudspeaker in a church. And this technique is patented by Active Audio. Just a word about the characterization of directivity. Arrays can be controlled with, can be approached with characterizing the wavefront to be generated. And also, this wavefront is not a beam, and that's a very different approach. Beam is a symmetrical pattern which assumes the far field, but in practice the listeners are not always in the far field, and the lobe is not symmetrical. So the beam is not a good way to characterize the directivity of such arrays. Opening angle and steering angle are not relevant. It is much better to characterize the array, the directivity, by their range, for example.